What's going on, guys? We're going to go through 3 rational problems. We didn't get a whole lot of examples done in class, so I want to give you guys a few more opportunities to watch us going through examples. I've got 3 from a worksheet. They look just like the notes, so let's get through these. Something I might have not been clear enough about in class is that we always need to factor if we can, okay? Because we want to know how much here we can reduce, and we're not really sure what exactly we can reduce yet. So we're going to handle this by factoring. On top, it's just a GCF left over with an x minus 6. That makes 4x. That makes 24. So that feels good. On the bottom, take out a 2, left over with x minus 2. And from here, we are able to do some simplifications. At the end of the day, these numbers are not hugely important. They're going to be our leading coefficients, which might affect our horizontal asymptote. But we could reduce this a little bit and put a 2 on top. That's fine because these numbers are not locked to anything. But these are locked. These are done. Can't handle that at all. And so to start, getting our asymptotes up there, I always like to start with the vertical asymptote. The vertical asymptote comes from, where is my bottom going to be equal to 0? So I'm looking at the bottom. And what number would make this 0 on the bottom? A positive 2. 2 minus 2 equals 0. I could also just say x minus 2 equals 0. Add the 2 to the other side. X equals 2. So I'm going to go ahead and use my ruler. Go ahead and make it straight up and down. But we need a vertical asymptote going in at a value of positive 2. Make a nice thick marker. There you go. There's my vertical asymptote. And we're moving on. Okay, horizontal asymptote. Horizontal asymptote. Horizontal asymptote comes from comparing the degrees. So I'm looking at the degree of the top and the degree of the bottom. I've got a degree of 1 and a degree of 1. So I've got similar degrees. And so I am going to want to use my leading coefficients. Horizontal asymptote should be a fraction of your leading coefficients. That would be 4 over 2. So for horizontal asymptote, I need to compare degrees. I've found that top equals bottom. And so y equals LC over LC, which is 4 over 2, which is just 2. So interestingly enough, I'm going to have a horizontal asymptote at y equals 2. So I've actually got 2 for both my asymptotes. Just a coincidence. Mr. Collier. That was third period, man. Or sorry, that was second period. Sorry. Bye. So I've got my asymptotes here. I need to go ahead and put in my curves of my graph. And where I'm going to go next is straight to Desmos. So I need to type in 4x minus 24, 2x minus 4. I'm going over here. I'm going to go ahead and type in 4x minus 24 and 2x minus 4. Checking out, double checking that this is right. 4x minus 24, 2x minus 4. Feels pretty good. I see that I'm going to be in the numerator and then in the denominator. So over here, throwing my lines in here. Let's use a blue color. That's green. Numerator, denominator. These don't need to be perfect. The main thing is that it needs to look asymptote, 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 right? All 4 corners should be in the asymptotes. So going back to Desmos, I can also figure out what my x-intercept would be. Obviously, right there, it's with the dot. The y-intercept, not as important, but it would be easy to find as well. 6, 0. So going back here, I've got a ton of information now, right? I can go for my vertical asymptote, x equals 2. My horizontal asymptote, y equals 2. My x-intercept, 6, 0. I can go for my domain, all real numbers, x not equal to 2. My range, all real numbers, y not equal to 2. My whole would be if anything crossed out. Now looking over here, I have crossed out my 2, my 4 and my 2 have been reduced, but these are not going to be things with an x. Okay, it's really only where x's are going to cancel out. And maybe I should have been more specific about that in class as well. But what I'm going to have is I crossed out a 2. 2 went away, and so when is 2 equal to 0? Because that's where my hole would be. 2 is not equal to 0, right? And so we're never going to have an issue if we reduce numbers like this. Now, if we had crossed out, maybe if I change this to a 6 here, now because an x was eliminated, we're going to have a hole. And that hole would be at x equals positive 6, because I would have to add that 6 to the other side. All that being said, no holes for this question. No holes. And we're done. Y'all do me a favor and just be a little bit quieter for me, just for another 6-7 minutes. So number 3, working through another rational equations. I've got definitely to start with some factoring, and this one is going to be factorable. It's a trinomial question. So on top, what multiplies to make 10, adds to make 7? That would be 5 and 2. So I'm going to have x plus 5, x plus 2. On bottom, x plus 5. And of course, this is canceling out. Now, as soon as I see this x canceling out, I'm thinking that's going to make a hole. Okay, so I might as well just go over here right now and just say there's a hole at -5. And again, it's going to be -5 because positive 5 right here, I need to move that 5 to the other side. If I plugged in a -5, that would be where the problem is. And now, when I look at this question, my vertical horizontal asymptotes shape my graph a whole lot. But my vertical asymptote, where the bottom is equal to 0, I don't have a bottom anymore. Right? I mean, I created a hole, but there's no more bottom equals 0. Right? It's just, there's only a 1 down here. Right? Because I have x plus 2 over 1. Where does 1 equal 0? It doesn't. Right? And so I actually am going to end up with no vertical asymptote for this one. I need to compare my degrees, 2 over 1. So my top is bigger. And what happens for your horizontal asymptote? Top bigger? None. And so I'm actually going to end up with no asymptotes on this question, which is definitely different from what we saw in the notes. It is possible, if we go to Desmos and we type this in, remember, our graph should look like this. This is the only thing left. So our graph is going to look like a regular old line. So if I type all this in, oh, please, there we go. If I type all that in, x squared plus 7x plus 10 over, oh, don't do that, x plus 5, it's a straight line. And it's a straight line because that's the only thing left, right? We simplified it to this, fraction x plus 2 over 1. The blue line and the red line are the same. This is just a regular old line. Now, the only difference between the blue line and the red line, this red line still includes the hole. And so if I look at this value of -5, where my hole is, if I look there, undefined, right? There's my hole. So the red function does have a hole. The blue function, if I take the red function away, does not have a hole, right? Because the blue function has removed that +5. That made the hole. So that being said, my graph is actually going to look like a regular old line with a slope of 1. So that's easy. That just means a nice little diagonal here. So our graph should look like this, but it also has, here maybe not, let's not use red, because red is our asymptote color, right? Our graph looks like that, but we do have a hole at -5. So right here is a hole. Holes aren't that important to draw when we have our curvy graphs, but on these straight line graphs, you probably do want to put a nice little picture here for the hole. Now we're pretty much ready to roll, right? X-intercept should be a piece of cake. X-intercept is right here, -2. Oh, pen's getting a little funky on me, guys. Sorry. -2, domain would be all real numbers, range would be all real numbers. But remember, The domain would be all real numbers x not equal to the whole, which would be negative 5. Now, technically, right, depending on if you're learning this from another teacher, you might be thinking, you're missing something, okay? If our graph, if we're thinking domain, exists all the way over here, not the whole, all the way over here, right? So our domain has a missing gap. How come our range doesn't have that gap either, right? Shouldn't we have a gap for our range? And shouldn't we also have, something over here? Y is not equal to whatever this is. And you're totally right. The truth is that I don't think that that's that important as a teacher. I don't think this year that we had enough time to go through that. But technically, if we look at our Desmos here, I have to use my mouse for this. We have this gap where we have our whole at negative 5, but the y value should have been negative 3, right? And so technically, we've skipped negative 5 in the x direction, and we've also skipped negative 3 in the y direction. So going back here, if we want to be, brainiacs, we can put a -3 there as well. Let's do one more question, and I'm going to go a little bit faster here just to show you how easy this stuff is, right? We need to go ahead and factor. That's GCF. Doing a little trinomial factoring, we're able to go ahead and cancel out. That's going to make a whole. That whole is going to be at negative 4. I guess up here, I could have mentioned, technically this is a whole at negative 5, negative 3. That's why this negative 3 has been used here. Again, I don't think that's that important. It's not on your test if you're sitting in my class. Over here, the only thing left over is this, just so that we have this written out. And so vertical asymptote would be bottom equal to 0. And so that would be a vertical asymptote at x. Ooh, not ready for that yet. At x equals 1, because that's where the bottom would be 0. So let's go ahead. Let's get our ruler back. Let's make it a straight up and down line. Let's go over here to 1. Let's make sure it's really straight. Let's draw a line. I got to be picky. It's not straight enough. That's good enough. And our horizontal asymptote would be to compare the degrees. We've got a 2. We've got a 2 and a 2. And so those are the same. So it's going to be leading coefficients, which is going to be 1 over 1. So we'll have a horizontal asymptote of 1. And let's go to Desmos and throw it in and see how it looks. Again, I can type in either one of these. They should still look the same. These two should still look the same. This one, the whole will be removed already. This graph will still have the whole included. So let's just type in the original. X squared plus 4x fraction x, not 2, x squared plus 4x. In the denominator, we have x squared plus 3 minus 4. X squared plus 3x minus 4. Here's our graph. Looks like it goes from low to high. So I'll go ahead over here and put that graph in. From low to high. Should be a little bit closer to the asymptote there, so we'll draw it a little bit better. We found that our horizontal asymptote should be at 1. So I'll go ahead and write that in here, y equals 1. Our x-intercept we haven't found yet. So let's look, our x-intercept, that's easy, 0, 0. And so if you look, we've missed it on our graph. As a teacher, I'm not super picky about that. If your teacher is super picky about that, your drawing might have to look more like that. Well, not really like that. More like this. It's hard for me to go straight down on this. More like that. But I don't really care. And our domain is all real numbers. Our range is all real numbers. X is not the vertical asymptote. X is not the whole. Y is not the horizontal asymptote. Y is not. Again, if you want to be super special, you want to find this Y value. Okay. At -4, we should have a whole. -4, we should have a whole. And what value is it going to be right there, right? As I look on the left side, 0.802, and on the right side, 0.799, I'm thinking it's going to be 0.8 right there. Thinking it's going to be 0.8. And I can try that if I type it in here, x over x minus 1, hide the green, go to -4, 0.8, I was right. And so this would be 4/5, which is 0.8. So this would be 4/5. All right, there's 3 more questions. Hopefully this helps you out. Hopefully the calculus kids weren't too loud in the background. They were kind of annoying me, but it is what it is. Hope this helps.